Alright, welcome back. We're going to finish off this problem set of integrating using u-subs by working out the remaining problems from the book, if you're following along. So we're going to work out problems 60 through 66. Here we go. We're going to start with this nice, easy trig one. So when we start out, we're going to let u equal cosine of 2 theta. We're doing this because the derivative of cosine is sine, and so I have that right here. So when I take the derivative, I'm going to get the derivative of cosine is negative sine of 2 theta times 2 d theta. The 2 comes from the chain rule from the negative sine 2 theta, but I don't want this 2 and I don't want the negative, so I'm going to multiply both sides by negative 1/2, and I'm going to get that this is equal to sine of 2 theta d theta. And now what we have to make sure we do is change our limits. So you get 0, well, if theta is equal to 0, then u is going to be equal to cosine of 2 times 0, which is just cosine of 0. And cosine of 0 is 1. And if we let theta equal pi over 6, we're going to get that u is equal to cosine of 2 times pi over 6, which is cosine of pi over 3. And cosine of pi over 3 is 1/2. Again, pi over 3 is the upper angle right here, so it's the smaller version of cosine. Alright, now let's do our u-sub. We're going to get this as the integral from 1 to 1/2 of u to the negative 3 times times negative 1/2 du. So this is the integral of negative 1/2 from 1 to 1/2 u to the negative 3 du. And then I want to take this time to actually flip my limits. I like having my smaller numbers on top. So the negative and the negative are going to become a positive. So I'm going to get 1/2 to 1, u to the negative 3 du. Now when I integrate, I'm going to get this as 1/2 times u to the negative 2 divided by negative 2 from 1/2 to 1. So this is going to be negative 1/4 times 1 over u squared from 1/2 to 1. So this is going to be negative 1/4, 1 over 1 squared minus 1 over 1/2 squared. So negative 1/4, 1 minus 1 divided by 1/4. So this is negative 1/4, 1 minus 4. Because 1 divided by 1/4 is 4. So this is negative 1/4 times negative 3. And I'm going to get positive 3/4 as my answer. Nice, easy cosine integral that looked kind of messy in the beginning. Okay, moving on to number 61. This is the integral from 0 to 7 of dx divided by x plus 2. So the first thing I'm going to do is I'm going to let u equal x plus 2. So I get du is simply just dx. Then if x is equal to 0, changing my limits here, then u is going to be equal to 0 plus 2, which is 7. And if x is 7, then u is going to be 2 plus 7, which is 9. Alright, so now we rewrite our integral. And this becomes the integral from 2 to 9 of 1 over u du. So the integral of 1 over u is ln of the absolute value of u. Don't forget to write the absolute value. Now that we know that all the values going into ln are positive, we can drop our absolute value signs. But you have to keep them until you know your terms are going to be positive. So this is ln of 9/2, which is ideally where I would stop the problem, but this is about 1.504, truncating at the third decimal. Okay, moving on to number 62, we get the integral of 2 to 5 of dx divided by 2x minus 3. Again, very similar, we're just going to let u equal 2x minus 3. So du is going to be equal to 2 dx. I don't want the 2 there, so I'm going to multiply both sides by 1/2. I get dx. And then I'm going to get x is equal to 2. So u is going to be 2 times 2 minus 3. So u is equal to 1. And I'm going to get x is equal to 5. So u is equal to 2 times 5 minus 3. So u is going to be equal to 7. So now we set up our integral. And this is going to be the integral from 1 to 7 of 1 over u times 1/2 du. So this will be 1/2 times the integral from 1 to 7 of 1 over u du. So this is 1/2 times ln of the absolute value of u from 1 to 7. So this is 1/2 times ln of 7. I can drop my absolute value bars because I know that these numbers are positive. So this is 1/2 times ln of 7 because ln of 1 is 0. So this is going to give me ln of 7 over 2, which is approximately 0.972. Again, truncating at the third decimal. Alright, moving on to number 63. So number 63 says the integral from 1 to 2 of 1 over t minus 3 dt. Same idea. We're going to let u equal the denominator. U is t minus 3, so du is going to be dt. So if t is equal to 1, then u is equal to 1 minus 3, which is negative 2. If t is equal to 2, then u is going to be equal to 2 minus 3, which is negative 1. So here we go. Let's set up our integral. Our integral is going to be from negative 2 to negative 1 of 1 over u du. And this is the reason why ln having the absolute value is so important, because we can actually solve this. So this is going to be ln of the absolute value of negative 1 minus ln the absolute value of negative 2. So this is ln of 1 minus ln of 2. And ln of 1 is 0, so negative ln of 2 is going to be your answer. And if you want to put that into a decimal form, it's about negative 0.693, again truncating at the third decimal place. Alright, moving on to number 64. We're going to get the integral from pi over 4 to 3 pi over 4 of cotangent of x dx. So before I even start this, I don't know the integral of cotangent off the top of my head. I think it's ln, the absolute value of sine. But there's an easy way to figure it out. I'm going to rewrite this using sine and cosine. So cotangent is cosine of x over sine of x. So this tells me that my u sub, u should equal sine of x. So my derivative, du, can be cosine of x dx. Because that'll be this piece right here. And now, if x is equal to pi over 4, then u is going to be equal to sine of pi over 4, which is root 2 over 2. So if x is equal to 3 pi over 4, then we're going to get u is equal to sine of 3 pi over 4. So u is going to be equal to root 2 over 2. At this point, we can effectively stop the problem because we know our limits are going to be the same. But I'm going to write out the integral just because. So this is going to be the integral from negative root 2 over 2. Positive root 2 over 2 to root 2 over 2 of 1 over u du. Again, noticing that these are the same, I can just put 0. Alright, number 65. This is where things start to get a little more interesting. We're going to let u equal our denominator, which is x squared plus 1. So du is going to be 2x dx. I don't want that 2 there, so I'm going to go 1/2 du is equal to x dx. So notice that that matches that perfectly. So if u is equal to negative 1, I'm sorry, not u, if x is equal to negative 1, then we get u is equal to negative 1 squared plus 1. So u is going to be 1 plus 1, which is 2. If x is equal to 3, we get that u is equal to 3 squared plus 1. So u is 10. So now let's rewrite our integral. We get this is the integral of 1 over u times 1/2 du from the limit points of 2 to 10. So this is going to be 1/2 times the integral from 2 to 10 of 1 over u du. So this is 1/2 times ln of the absolute value of u from 2 to 10. So this is 1/2 ln 10 minus ln of 2. 1/2 times the ln of 10 over 2, which is going to give me 1/2 times ln of 5. And if you put that in a calculator, you get that as about 0.804, again truncating at the third decimal place. The integral from 0 to 2 of e to the x dx divided by 3 plus e to the x. I like e to the x's, I think they're fun. So u is 3 plus e to the x. E to the x is very nice because the derivative of e to the x is just e to the x. Again, notice that this matches this. We're good to go. If x is equal to 0, then u is equal to 3 plus e to the 0. So u is going to be 3 plus 1, which is 4. If x is equal to 2, then u is equal to 3 plus e squared, which is just 3 plus e squared, nothing to do about that. Now we're going to write our integral. We're almost done. We're almost there. Let's go. So we get the integral from 4 to 3 plus e squared. 1 divided by u du. Integration is nice and easy. It's the ln of the absolute value of u from 4 to 3 plus e squared. So this is ln of 3 plus e squared minus ln of 4. I know e is roughly 2.7, and so I know 3 plus 2.7 is positive. That's why I can drop my absolute value bars. So this is ln of 3 plus e squared divided by 4. You plug all of that into a calculator, and you get roughly 0.954. And that's how you do integration by u sub.